Students, let's talk about Tokomok. Tokomok was another technique advised for the confinement of plasma. And before I can say anything about Tokomok, let me first try to draw a rough diagram of a donut. So, not sure whether I'll be able to do justice with the diagram, but I'll try my level best. Okay, it's a shield, and we have wire woundings on this shield through which current is allowed to pass. And here we have axial plasma current, and we have plasma here, and we have helical magnetic field. So we have poloidal field, and we have toroidal field. Now, this Tokomok is a device basically to achieve the fusion in a toroidal chamber subjected to the magnetic field. And this word Tokomok, what it means, it's a Russian name. It's a Russian name. And it simply means toroidal magnetic field, toroidal magnetic field. And it was devised by a Russian physicist. What was his name? Arismovich. His name was L.A. Arismovich. And he evolved this device in 1968. And in a Tokomok, what we have is the experimental gas that we have from where we have to create the plasma. It is first brought to very, very low pressures. It's brought down to the low pressures of the order of 10 to the power of minus torr. And then this gas is induced into the toroidal chamber, and the advantage of this toroidal shape is that it's being endless for the particles inside this toroidal chamber, and the question of escape of the plasma through the ends does not arise. And now, after 1968, when convincing evidences of the Tokomok confinement were reported, many of the experimental devices were built. Some of them were built in the United States, and some of them were built at some other places. Now, as experience has been gained with this Tokomok operation, large machines have been constructed to increase the plasma within the Tokamak operations. So what scientists around the globe are trying to do is they are trying to develop the machines by virtue of which they can enhance the confinement time of the plasma within this device. Now, in particular, this plasma stability is improved. It has been improved if the height of the torus is large relative to its horizontal diameter. Okay, and what it means is that the torus has the shape of a fat or a donut. It has a donut shape with a small central hole. Now, a very strong toroidal magnetic field is created. How is it created? It's created by sending the current through the coils of several wounds in this toroidal chamber. The motion of the charged particles across this field is impeded. As a result, the particles execute the helical motion with magnetic lines of force, as on this axis of this donut. Now, in fact, what happens is that they move along this magnetic field and hence remain confined at a distance from, at a distance from. So, at a distance from. So they remain confined at a distance from the chamber wall. But due to the gradient in curvature, so at every point there is a gradient in the curvature of the plasma. What happens is that positive and the negative particles, they keep on moving in opposite directions, resulting in the separation of charges. And the plasma is then driven out due to the electric field. So making use of electric field is developed in this way. Now, in order to circumvent this effect, a relatively weak polyidal magnetic field is created by sending a current across this toroidal direction. And by sending the current in this direction, a weak magnetic field is executed. Now, if the ratio of this, what we have is we have toroidal magnetic field, and we have polyidal magnetic field. Okay, the magnetic field that's in this direction. Now, if this ratio between toroidal magnetic field and polyidal magnetic field is greater than some critical value that has been assigned, the different types of instabilities can occur within the plasma. And the critical value certainly depends on the shape and volume of this torus that we have. And energy loss in the tokamak is mostly due to the high thermal conductivity of electrons. Electrons being lighter, faster. So the loss of energy is due to these electrons in plasma, because plasma has in it it has ions and electrons. So intense efforts are needed to study the effect of this aspect ratio, the ratio between toroidal magnetic field and polyidal magnetic field, and the ratio of the major and minor radiuses of this torus. This torus having major and minor radiuses, that ratio has to be modified, and that ratio has to be improved. And non-circular cross section has to be improved. RF heating has to be improved. Injection of fast neutral atoms has to be introduced. So from one generation of Tokomok to another coming generations of this Tokomok, the Lawson criteria is slowly being approached, and hope of the successful fusion reactor is. It seems to be within the fulfillment. Nobody has reported it till now, whether whether anyone has actually designed a fusion reactor, a controlled fusion reactor. But a few of tokamaks are there. I mean, there is what's called that TFTR. This is a Tokamak fusion test reactor in USA, and then there is T10, T10 and T15. These are the tokamaks from Russia. Then we have JT. JT, it's from Japan, and JET. JET, that is Joint European Taurus, England. So many of the countries have been trying for achieving this tokamak, where we can have controlled nuclear fusion.